What's happening, guys? Scott from A Hornet's Nest, and welcome back to episode 5 of Tutorial Tuesday. It is so good to see you, and in today's episode we are going through the basics of Arduino coding and why it is important to be able to learn from the ground up and not just copy and paste code. That way, when you're following my tutorials or anyone else's online, you can follow along and understand why they are doing it the way they're doing it. There's no point in me jumping into a really cool F-18 Hornet project, showing you some complex code, and then you'd be like, oh, I wonder why he did it that way. Oh, I wonder why he used that function. No. I'm going to be teaching you the basics and the fundamentals, and we're not starting this Hornet project until we are all at a level that we can follow along. That way everyone's included. Now, if you already know how to code Arduino and you've already got it downloaded, still keep watching because you might find something useful out of this, but the next couple of tutorials are definitely for you. But for those that have never seen an Arduino in their life before, this one's for you, and let's get started. So what we got to do is download a program called Arduino IDE 2.2.1. It is the newest version of the Arduino Integrated Development Environment, and that's where we're going to be writing our code. We're going to be able to find it here at the arduino.cc website. And we're going to go to the software tab and download Arduino 2.2.1. And I'm going to be doing it for Windows 10. Just download. It starts downloading. Wait for it to download. We're going to be able to find it here in our downloads folder, selecting the application file, installing it. And then at the end, we're going to press run, opening up the IDE. Now, to get started, we're going to need an Arduino, and that is it. We don't need any external hardware. We don't need lights, switches, wires. Everything for today's tutorial is just on this. Now, I'm using the Allegro Arduino Mega 2560 because it came in the Allegro, the most complete starter kit. No promotions here, is purely an incredible starter kit by Allegro. It's got all the inputs and outputs that you could possibly imagine for all sorts of projects, and it's at a reasonable price on Amazon. So, if you want to follow along, you're not going to need one of these, but I do recommend it. That way we all have the same hardware and it's going to be a bit easier. Alrighty, now that that is all installed, let's go in and plug our Arduino in and actually have a look what we're going to be doing in today's tutorial. Because you're probably thinking, hey, I've got no hardware, I've got no LEDs, I've got no lights, I've got no switches. How can I possibly join along on this tutorial? Well, all you need is the board and it connected to your computer. Because on all Arduinos, there is a little LED that has the letter L next to it. And that is connected to the 13th pin, or pin number 13. You can see on my board here, we've got a lot of numbers running along the sides, and they are the pin numbers. And then on the Mega, it's nice because they've got them along the sides here as well, telling you what types of pins and how they should be used. Now, let's say you've got a little Nano at home. It's just a tiny little Arduino, great for small projects. It there has a little L as well, and that LED is the one that is going to be connected to its pin 13. So, now that we know what we're doing, let's get into the coding. With IDE loaded up, we can see a big screen in front of us with a large area. This large area here is called the sketch. It is where we write the code, it's where the magic happens. I'm not referring to a picture, I'm not referring to a diagram. It is the sketch or the written code of the Arduino. In a sketch, you've got void setup and void loop. These two always have to be in your code, otherwise Arduino doesn't know what to do. The void setup runs once and only once, and it initializes the board. It tells the board, I want these pins to send out signal, I want these pins to bring in signal. It sets values for different parameters. You've got a whole wide world of things that you can set the board up with, but it only runs once every time the board is powered up or reset. Now we've got void loop. Well, void loop loops continuously. It will loop into infinity if it could, if the board didn't naturally break down. It is where we put all our main pieces of code that we want to run repetitively. Then above the sketch, we've got the option to select the type of board we're using. With the Arduino connected, we can select the board and you can see that the Arduino Mega shows up as a COM3. Now the COM could be completely different for yours. It could show up as COM4, COM5, COM1. It depends how your computer has recognized it and when in the sequence it got plugged in. As long as you see the Arduino Mega or whichever one you're using, that is the one you want to select. If you're running the legacy version, and that's IDE version 1.8 point whatever, it is under Tools, Port, and you can go and select your COM. And then you can go select your board under the board section, and there is the whole list of all the compatible Arduinos that can be used with this IDE. So now that we know where to write the code, how to select the board, and what we're going to be doing, let's go and turn this LED connected to 13 on and off as our first pieces of code. Real simple, but really effective because you're going to use this as the base of all your knowledge and it's going to flow into the next tutorials. So what do we want to do? Let's tell Arduino that we want pin 13 to send out data. So let's go and look at our first function, and that is pin mode. It is where we're telling the Arduino what we want that pin to do, what its job is. So we're going to use what's called bumpy text. It's where the first letter of each word is capitalized, apart from the first word. So we're going to go pin mode. It allows us to be able to easily read words that are joined together without spaces, and it's pretty common in coding. Open bracket, and the first thing you see is it went orange. That shows that it is a valid function within the Arduino IDE, and you can highlight over it and it says the parameters within it is the pin and the mode. Ignore what the UINT 8_t is. That's just a coding way of saying this is the type of parameter I'm expecting, but I'm going to tell you what they are so you don't have to try to learn them all. Pin mode, the pin is 13, it's just a number, comma, and the mode is either an output or an input. And for these, they are all capitalized. So output, close brackets, and you always finish Arduino code most of the time. There might be a couple where you don't need a semicolon, but 99% of the time, you've got to finish each line with a semicolon. There we've got it. We have just written our first line of code, and it really wasn't that hard, and it's going to be used in all your applications from now on. You've got to tell the Arduino what the pin is doing, otherwise you could get possible errors when it's like, I don't really know what you want me to do with this. I'll give it my best go, but don't yell at me if it doesn't work. So if we identify all the pin modes, we're not going to have that issue. So let's get down into the void loop, and this is where we are writing the code that we want to run repetitively. Now, what can we do with an LED? We can turn it on, or we can turn it off. That's the function of an LED. And then you've got varying brightness levels as well, but that's all LEDs do. They turn on, they turn off, they turn on, they turn off. So, but how do we do that? Well, the new function we're learning is digital write. We are writing to the LED in a digital way. Now, how do you write in a digital way? It's Arduino's way of explaining it, but a digital write is where we are sending a binary state, whether it's on or off. Now, for the digital write function, you can either write as high, which is your sending signal or sending voltage to the output, or you can write low, which is 0 volts, and you're sending no signal to the output. So you can imagine with an LED, if we wrote high, we get brightness. If we write low, the LED is turned off. So let's go here and send a high signal to pin 13. Now we're going to use bumpy case again, digital write, open brackets. It goes orange, showing that we have a correct function. We've got the suggestion up at the top here, or we can hover our mouse over the actual words and we can see it a bit bigger. And it's saying we need a pin and we need a value. Well, we know what the pin is. It's pin 13. We put our comma, and then we need a value, and we've said we are writing high. So capitals again, close bracket, colon, and there we've got it. We have just written 2 lines of code, and we're going to have the magic work now when we go to the arrow at the top and click upload. So revising, the pin mode tells you what the job of the pin is, and digital write says, hey, I want you to either turn this on or turn it off. So let's have a look here. We're gonna press upload, uploading, all done. And there we've got it. That light is turned on and it's gonna stay on. It will stay on for infinity until the LED burns out or the Arduino breaks. It is not stopping. And the reason for that is it is in the loop. Now, how do we turn it off? Well, we do the opposite of high, and that is low. So we can go digital right, pin 13, capitals again, low. We're gonna upload, compiling, uploading, complete, and it's gone and turned our LED off. We've just done 2 bits of code. That's 2 programs you've written on the first day of class, and that's pretty cool. So what can we do with this info? Like, why are you making me turn lights on and off, and what's the purpose of it? You're going to be using digital rights throughout your entire Arduino process, and it's not just for turning lights on and off. It can be for anything. What we're saying to that line of code is send voltage to that pin or take voltage away. Now, if we can turn a LED on, we can turn an LED off, theoretically, we should be able to make a LED flash. Well, let's go do that. Let's turn it on first, and we're going to use digital right, open brackets, we get orange, we've done it right. 13 is where we want to send it. High is what we want to send. Close brackets, colon. So the loop is going to say, turn it on, turn it off, turn it on, turn it off, turn it on, turn it off, and it's going to theoretically flash. Let's send that. Uploading, done uploading. Well, that's just looking like a dim LED. That's not flashing at all. But why? Well, what's the computer doing? It is sending high, low, high, low, high, low so fast that our brain can't even compute the flashing. It's just going to show us a dim LED. So the way we get to fix that is with our third function today, and that is delay. Delay pretty much tells Arduino, take a break, go out for lunch, come back after the delay period is finished. So what we're going to do, in between the high and the low, we're going to write delay, open brackets. It's got delay. The type is an unsigned long. Doesn't matter what that is. That's going to be later tutorials. What we're looking for here is millisecond. Well, there's 1000 milliseconds in a second. So why don't we just turn it on and off on a second intervals? 1000 milliseconds, close brackets, semicolon. Well, we've turned it on for 1000. We need to turn it off for 1000 as well. So delay, 1000, closing, semi. Lovely. So now we can turn it on for a second, turn it off for a second, turn it on for a second, off for a second. Let's go have a look at what that looks like. Uploading. There we go. We've got it. We have a flashing LED. It wasn't that hard, was it? It was using a bit of brain to think, how do I want this to work and why is it working that way? And then we'll be able to solve it. That's the problem with copying and pasting people's code without understanding the fundamentals, is debugging it is really, really hard. You'll get there eventually, but don't waste your time trying to debug other people's code, just write your code. So we know how to turn it on and off now. Let's see if we can adjust its tempo or its frequency. Now, if we want to make it flash faster, we just tell Arduino, hey, don't take as long of a lunch break. So why don't we make this 200 milliseconds? Make this one 200 milliseconds. And let's see what that looks like. Uploading, there we go. That's quite quick. That almost has the same frequency as a master caution light. Maybe this is how we do it. You watch this space and watch a digital right come into play when we start doing master caution lights. So we know how to do a master caution light flash. What happens if we do it quicker? Well, let's go 20 and 20. So it's on for 20 milliseconds, off for 20 milliseconds, rinse and repeat. Uploading. Oh, now we're getting somewhere. That's quite quick. What if we do it a bit quicker? What about 5? There we go, it's pretty much now a steady light. What's happened is it's flicking too fast for our brain to be able to compute how the frequency is going. We can't see the off period, all we're seeing is the on period. So there will come a point in the delay sequence that the brain just cannot compute anymore and it looks steady, and what that's called is vision persistence. Now you don't need to have equal values for each flash, that's just silly. Why don't we go have a look at making it turn on for a second and off for 1/10 of a second, or 100 milliseconds. Uploading. There we go, and you can see it turns on, the quick flash off, turns on, the quick flash off. Alrighty, so that's pretty cool. We have just gone and learned 3 new functions, especially if it's your first day Arduino coding. We've learned how to assign the job to a pin through pin mode being an output or an input. We've learned how to digitally write to something, turning it on and off using high and low. And we've learned how to send the Arduino on a break and come back later by using delay and assigning it a time in milliseconds. So that's pretty cool. You can be pretty proud of yourself having written your first 3 bits of code, and it only gets cooler from now. Now in the next episode, we're going to look at how to bring information into an Arduino instead of sending it out. And you guessed it, that is what it's like when you're pulling information in from a switch or a circuit breaker or a potentiometer like a volume knob. And that's where we get into actually coding Flight Simulator panels. But before we go, how about you try and play around with the code we've just written today and create a flashing sequence that replicates the beacon light of an aircraft. Now that is the red flashing light on the top or bottom of the fuselage, warning ground crew that the aircraft's engines are about to start or they have started and they better keep clear. But guess what? We can go and make a real beacon light flash off our sims to make it look like the red glow around the plane when it's nighttime. So, hope you enjoyed today's tutorial. It's only going to get better. I'm going to make sure that we only progress at the right pace so everybody can keep up. And anything you learn in these tutorials, you do not need any prior learning, because I'm going to be teaching it to you all. So that's it for today. 3 simple functions. I hope you got something out of it. And as always, stay safe, enjoy your flight simming. I'll see you next episode where we learn to code switches and how to read them.